So my name is Rémi, and I'm part of OpenPassport. And back 6 months ago, we realized that many applications still need to verify the identity of their users online. And today, that's still hard because they are stuck between centralized KYC solution and other technologies such as WorldCoin, which still need to deploy their infrastructure. But fortunately for us, the International Civil Aviation Organization already built a nice tool on which we can piggyback on, which is the electronic passport. This is issued in more than 170 countries and hosts an electronic chip with inside a bunch of data about you, which is signed by the issuer country, meaning that we can generate ZKP over that. And by doing so, we can already target several issues related to identity, such as Sybil resistance, how to prove that it's a human who's behind an action, a vote, a tweet, or anything else, selective disclosure. You may want to prove that you are older than 18 years old or that you are part of a specific country without revealing anything else. Or even compliance. Using OpenPassport, you can already prove that you are not part of the OFAC list without revealing anything else. So unfortunately, we don't have time for the demo, but we can go through the UX so you will have a better idea. So the first step is obviously to scan your passport with the camera. It's not taking a picture, just reading some field. Because in the second one, you are going to read the NFC chip of the passport using the NFC reader of the phone. And this chip is protected by a password, which is the passport number, the birth date, and the expiry date. So that's why we need in the first time to do OCR reading on the main page of the passport. Right, so now let's say that my passport data are onboarded inside the application, meaning that I can now generate some ZKPs about that. So let's do so. An application that wants to integrate OpenPassport will just have to display this kind of QR code. So using the application, I will scan it, and it will show me what the application wants me exactly to disclose. So in this example, let's just prove all of that in one ZKP. It's pretty rapid. Yeah, this is the real-time flow. And that's it. The proof is verified. So about what's happening really under the hood. So this is the main flow of the circuit. It's pretty straightforward. So in this one, users are going to generate a proof of passports. And by that, I mean verify the integrity of the data, verify also the signature of the passport, and optionally disclose other information, such as the one we talked about before. And that's it. You take the ZKP and you send it to the verifier. That's good, but we can still do better than that. So we actually have a second setup, which is close to the one of Semaphore. And in this one, first, users are going to generate a proof of passports. So verify the integrity of the data, verify the signature of the passports, but they are not going to disclose anything. Instead of that, you are going to generate a commitment, which is a hash of a secret and the passport data, and increment a commitment Merkle tree with this commitment. Meaning that in a second time, you can now reuse this commitment to generate ZKPs about your passport data. And the good thing is that now there is actually no way to link the final ZKP that you're sending to the application with your first nullifier, which is, of course, generated deterministically on your passport data. So that's really powerful for use cases such as voting. Right, about the tech stack, we are using Gross16 and SciComm, and the main issue is that the ZK are really heavy, right? Because we are doing a bunch of hash operation and verify signatures, but we want everything to be achieved client side, right? So like that, the passport data will never leave the device. So the thing is, we can't actually ask users to download 1 or 2 gigabyte ZKs. So we actually want to move to another proving scheme, which is Spartan. And that's why during this residency, we built a Spartan verifier in SP1. You can see the benchmark here. It's around 800 million cycles. So that's huge, but there is no precompile yet. So this is obviously the next step. Right, yes, final slide. I didn't do a demo, but you can try the app by yourself. So you can flash this QR code or go directly to openpassport.app/playgrounds. And you can download the app, scan your passport, generate some ZKP and verify them. And if you don't want to use your passport, or if you don't have it, you can actually generate more passport data inside the application. So that's it.